Alright, welcome back. We're going to do dividing rational expressions in this video. Okay, if you have not watched the multiplying video, you should go do that first and then come back for this one. Okay, so with dividing, I know that we've talked about this many times this year, that we know that when you have a dividing a fraction, we need to do keep, change, as it was called for you by your teacher, whoever that was, I can't remember. So we're going to always flip that second fraction over, okay, and multiply by it instead. And then we're going to get 33 over 14. And again, if we could have cross-canceled, we would have. And if we could have reduced, we would have. But in this case, we can't do either. So that's a final answer. Okay, and then same thing here with 8 over 5 divided by 2/15. We're going to keep, change. Okay, so you see I'm just turning over that second fraction and multiplying by it. This is a really important skill. I'm not going to go over it really more than that, but you will need this today in this lesson. Okay, I can see some cross-canceling opportunities here. That's supposed to be a 4, but it looks like absolute gobbledygook. Let's try that again. There we go. And I can see that we can divide this one as well by 5, and then we get 12 over 1. And then remember that we always simplify as far as possible, so that's just 12. Okay. So there we go. We are going to keep going. We did multiplying last video. Now we're going to talk about dividing. It is very similar to multiplying and to dividing fractions. We're going to do keep, change, and then look at NPVs. But NPVs, big topic in this lesson. Remember that when we are looking at NPVs, we're looking at what makes a denominator 0. But when we do this division, we start with, let's take a look at this first example. Okay, we start with this denominator and this denominator, right? But then when we do keep, change, let's just write this out. All of a sudden, we've created a third denominator. Okay, and so for that reason, we need to find the NPVs of all three of those terms or spaces, okay, not just the original denominators. And that's because at this stage of the question, this term is the 0 problem, and then at this stage, then this is the 0 problem, if that makes sense. Okay, so I've written that out kind of in different wording here, that we need to remember that the entire divisor, that's the entire second fraction, can't have a value of 0. So we will include all of our values that make any of these three equal to 0 as NPVs. Okay, so let's just do this first question. I'm going to stop talking and do math. For the record, it's not essential that you write NPVs. Okay, so if you just started over here, it'll be fine. I would understand what's going on. So I'm going to start here, and I notice that x can't be 1 from this one. And then I know that x can't be 4 from this one. And then from this last one, I know that x cannot be -1. Okay, so as long as you're thinking about those somewhere along the road, we are doing well. Okay, and then I'm going to multiply across. And I get, oh my goodness, you guys, what is happening today? Okay, now do I have any identical sets of brackets? No, I do not. Okay, and so because of that, then that's all. And I'm just going to write out my NPVs, and then the question, in this case, will be over. If I had identical brackets, of course, I would simplify. Okay, let's zoom into this one, give myself a little bit more space. I'm going to choose another color. Fun times. All right, so NPVs. Remember that we need to do this denominator, and then this that will become a denominator. Okay, so we're going to do all three of those. So you can see that x cannot be -3, x cannot be 5, and x cannot be 2. Okay, so again, from here, here, and here. Essentially, when you do division of rational expressions, the only one you don't care about is the first numerator. Everything else you have to find NPVs for. Okay, so we're doing keep, change. So we're going to get x minus 2 over x plus 3, multiplied by turning over x minus 5 over x minus 2. Okay, so again, your choice as to whether you cross-cancel or not. I personally do find that probably more people make mistakes when they cross-cancel, but it's totally fine if you want to. I'm not going to say no. So I have an identical bracket here, so I can cross those out. And then I get left with x minus 5 over x plus 3. Do I have any identical brackets left? I do not. Therefore, I cannot cancel anything further. And I just write out my NPVs to finish the question off. Okay. All right, now, what happens when we need to factor? I hope you didn't think we wouldn't factor this time, because of course we will. I love factoring. Okay, so first denominator we need to look at. This is a lot of denominators. I know that, okay? I'm sorry about that, but it is part of the game here. So we are going to factor this to see that we have x plus 2 cannot equal 0. And then that's our happy instance again, where if we were to set each bracket not equal to 0, it would give us the exact same thing. So we only need to set the first bracket not equal to 0 to get x cannot be negative 2. Second denominator. We have x times x plus 1 cannot equal 0. So that means that x cannot equal 0 and that x cannot equal negative 1. That's not a 1. There we go. Let's see if I can get this last one in here. And, okay, you can like put, oh dear, sorry guys. You could put like little lines between if that helps you keep yourself organized. I actually often do that, but you don't need to. Just another good suggestion if you'd like it. Okay, and then we get x minus 3, x plus 2 cannot equal 0. Okay, so remember to factor when you see this, okay? Don't do any crazy addition and subtraction across the not equals. Factor it first and then we'll deal with it. Okay, so there we go. Those are all my NPVs. I know that's a lot, but remember that this is 2 birds with 1 stone because we're going to need to factor these all anyways, so now we've already done like a bunch of the work by doing all that factoring. So, keep, change. Oh my goodness, you guys, why is my stylus doing this to me today? It's usually like so much nicer to me than this. Okay, keep, change means we're going to turn over the second fraction to get x squared minus x minus 6 on the top in the numerator, and then x squared plus x in the denominator. Now, I'm going to factor. This is the only set of terms I have not factored, so that's the only one I actually have to think about right now. And I can see I have a GCF, of x, so I can factor that out. Then I have x plus 2, x plus 2. And then I already did this one as well. Okay, so I'm just reading all of this factoring off of the work I already did. That's so great. Work smarter, not harder. You know how I say that. And then we're going to put this all together. Now, you're going to notice there is an x just kind of in the middle here. I personally would recommend you always put that x out the front because otherwise it's kind of like easy to lose it. It's like small, it doesn't have brackets around it, it looks a little bit different than everything else, so sometimes people forget about it. Of course, again, that's not like you have to do that, but I would recommend. And that also gives us an easier place to just see that we can cancel those x's, right? Because this x is being multiplied by everything else, and same with this one, no addition or subtraction. So just one x and one x, we can just cancel them out. Then other brackets that I'm seeing here is x plus 2 and x plus 2. And am I seeing anything else? No, I think that's it. Okay, great. I am doing this example on the fly, you guys. Okay, I don't have any notes with me. I'm just like doing this while I talk. So if you catch a mistake, just message me and I will gladly make an update post. Okay, saying that I made an error, and I will write out the correct answer if that ever were to happen. And of course it could, because I am a human, so there you go. Okay, so now that we're here, I have, let's see, do I have any identical brackets? No, I do not. I do not see an identical bracket going on here. And so because of that, I'm just going to put my NPVs in next to this. And that will be like the finishing up of my answer. That's the final step. Okay, so I have a -2, I have -1, I have 0, and I have 3. And another quick note again, remember that even if I have the same thing twice, I don't have to write it twice because it's already indicated in the answer. Here by putting a -2. We've already covered that base. Okay, so there we go. All right. Maybe I should have written those NPVs underneath, but oh well, too bad. Okay, at this point, I would recommend that you pause the video and try this example. Okay, there's a lot of factoring in that one as well, and that's why I want you to try it, is because it's easy to mix up our factoring or that kind of thing, so I just want to make sure that you guys have a chance to practice. So pause it, and I'll come back with the answer. Okay, so let's do this last question. I should have picked color already. Sure, it's not the nicest green, but we'll roll with it. Okay, so again, this, and this are all going to be denominators at some point in this question, so let's factor them all to find their NPVs. Okay, oh dear. Okay, so lots of you I know will like start your question like this. Okay, this is also another side note, and that's like fine. Okay, you're allowed to do that. I don't care which order you fill these in, as long as you get your numbers in properly. I've had questions about that all year, so just wanted to mention it again. Okay, so this means x cannot be -7, and it also cannot be 2. And then I'm going to go, oh dear, go to the next one. Okay, so next possible denominator is x squared plus 4x plus 3. Which means that x plus 3 times x plus 1 cannot equal 0. And that means x cannot be, oh, I don't need that bracket. There we go. X cannot be -3, and x cannot be -1. And last but not least, this denominator, I'm going to get x squared plus 8x plus 7 cannot equal 0, which means that x plus 7, x plus 1 cannot equal 0, and therefore x cannot be -7, and x cannot be -1. Okay, that's a lot of factoring, I know, but remember, we're going to use that again right away here, so it's good that we did it. All right, the last denominator to be factored is here. I will factor it once we do keep change. Okay, so I'm flipping over that second denominator, or that second fraction, pardon me, so that the denominator is now the numerator and the reverse. And then we're going to factor anything that we haven't, and since we have factored most of it, that's great. The only one we haven't factored is this first numerator, and there we go, now it's factored. Oh boy, I really didn't leave myself enough space here. Let's see if I can write this out nice and small. Woo! Okay, there we go. Now, I'm going to cross-cancel this one first because I know some of you prefer that. So, just to show you both methods across the examples on this page. But again, if you wanted to multiply it all into one big fraction and then cancel, that's fine. Okay, so I'm going to see x plus 1 is the same here. And what else do I see? X plus 3 is the same. Oh, and x plus 7 as well is the same. So that actually just leaves me with x minus 5 and x minus 2. It's not very much. And are those the identical factors, pardon me? Nope, they are not. The 5 and the 2 are different. We cannot cancel anything. So, oh, that's a fancy thing that has never happened before. Okay. There we go. Now just add my NPVs. And then we call it good to go. Again, like I've said before, I like to put these in increasing order, but you don't have to. They can be in any order at all, and it's not wrong, okay? So don't worry about that if you were thinking about it again. And there we go. That's an answer, okay? There is a worksheet on the next page, okay? Answers at the bottom. And again, you can leave everything in factored form. That is totally fine. It's easier to kind of analyze and look at and also to work with than having to like foil everything back out. Kind of a waste of time. Okay, so that's it for the really official stuff, okay? In the next video, I'm going to talk about this. I'll do a short video on this. And then if you want to look at the last one, I'm going to put the answers up for that. Okay, so it's totally up to you. But this is the kind of like the cutoff, the last lesson of this unit and of this year. So congratulations. Okay, I'll talk to you soon.